I want you to try a little thought experiment with me. So imagine, just for a second, holding your breath for over 20 minutes.
Okay, that sounds pretty awful already.
Right. But wait, it gets worse. Because while your lungs are literally screaming for air, you are diving 500 meters down into pitch black, freezing ocean water.
No thanks, I'm out.
Yeah, but then you finally come up to the surface and there's just no relief at all because you are about to spend the next, 120 days standing on a sheet of solid ice, eating absolutely nothing, all while getting battered by minus 40-degree winds.
I mean, honestly, that sounds like some kind of intricate torture method from Greek mythology.
It really does, right. It sounds completely impossible for any living creature to survive. But this isn't science fiction. And it isn't some weird extreme human endurance challenge. This is just the everyday reality for the emperor penguin.
It's wild to even think about.
It really is. So in this deep dive, we're unpacking a literal mountain of biological research on these guys, from their just incredible anatomical engineering to their highly precarious life cycle. We're looking at how they survive, why they behave the way they do, and, the really sobering April 2026 declaration that officially placed them on the endangered species list.
Yeah, and I think it's important to frame this right, because when you hear emperor penguin, it is so easy to just picture a cute, waddling bird sliding around on a glacier.
Totally, like in the movies.
Exactly.
Yeah.
But we have to completely reframe how we view them, because emperor penguins are, they are highly specialized extremophiles. Like, their entire physical structure, their complex behavior, reproduction, every single aspect of their existence relies on this razor-thin, delicate balance with one of the most violently harsh environments on Earth.
Okay, let's unpack this. Because to really understand how they survive the Antarctic, we first have to look at what happens when they actually plunge into that freezing ocean. And these are not small, lightweight birds we're talking about.
Oh, not at all.
No, we are talking about the tallest and heaviest living penguin species on the entire planet. They stand an average of 115 centimeters tall, so getting really close to 4 feet. And they can weigh anywhere from 22 to 45 kilograms.
And, they really need that immense mass for what they do beneath the surface. You mentioned the 20-minute breath hold earlier.
Yeah, which is terrifying.
It is. But biologists routinely track them, diving to depths of up to 535 meters.
Wow.
Yeah, and there's actually a recorded dive of one individual reaching 564 meters, staying completely submerged for almost 22 minutes.
Wait, 564 meters. If a human tried this, our lungs would crush like a cheap soda can under that kind of pressure.
Oh, absolutely.
I mean, you're dealing with pressure up to 40 times greater than at the surface. So instead of wearing like biological scuba gear, their bodies are essentially built like solid submarines.
That's actually a really great way to put it, because most birds possess hollow air-filled bones, right? Which is an evolutionary adaptation for flight. It keeps them light.
Right.
But emperor penguins have entirely solid bones. So by eliminating those internal air pockets, they completely remove the risk of mechanical barotrauma.
Which is getting crushed by the pressure.
Exactly. The immense deep-sea pressure simply has nothing to compress, so their skeletons just don't crush.
Okay, so that handles the pressure aspect. But what about the oxygen? Because if you hold your breath for 20 minutes, you black out and drown.
Yeah, they manage this through extreme internal regulation. When they dive, their heart rate drops drastically, going as low as just 15 to 20 beats per minute.
15 beats, that's barely beating at all.
Right, and they selectively shut down blood flow to non-essential organs, basically redirecting everything to just the brain and the heart. But the real secret is actually in their blood chemistry. They have this uniquely structured hemoglobin and myoglobin.
Wait, hemoglobin is what carries oxygen in our blood too, right? What makes theirs so different?
So their molecular structure is modified to bind to oxygen much more tenaciously. A human's hemoglobin releases oxygen steadily as we need it. But the emperor penguin's proteins are structured to basically hoard the oxygen and then selectively release it.
Oh, wow.
Yeah, this allows them to remain conscious and active even when the overall concentration of oxygen in their blood drops to levels that would cause a human being to instantly pass out.
But I guess my question is, why go through all this physiological extremity just to get a meal? Going down 500 meters seems like an incredible waste of energy.
Well, they need this specialized physiology to execute highly complex sub-ice foraging strategies. The food isn't just, swimming out in the open waiting for them.
Fair point.
So one strategy actually involves the penguin diving 50 meters deep and then looking back up toward the bottom surface of the sea ice. They spot fish swimming right against that frozen ceiling.
Ah, I see.
Then they swim rapidly upward to ambush them from below. And they will execute this upside-down hunting maneuver half a dozen times on a single breath before they even surface.
Hunting upside down beneath a frozen ceiling is just a terrifying image. But, looking at the biological data, it makes it clear that their true endurance test happens entirely out of the water, which is crazy.
It really is.
Because when most animals sensibly flee the Antarctic winter, the emperor penguin just turns around and marches straight into it.
Yeah. Around March or April, triggered by the days starting to get shorter, they actually leave the relative safety and warmth of the ocean.
It is already freezing.
Right, but warmer than the surface. And they trek anywhere from 50 to 120 kilometers over solid, shifting pack ice just to reach their breeding colonies.
And once they arrive, courtship begins in the pitch black of winter. We're talking about these ecstatic vocal displays, which basically involve a lot of very loud, very complex posturing and calling.
And contrary to popular cultural belief, they do not mate for life. They practice what biologists call serial monogamy.
Yeah, the fidelity rate between years is remarkably low. It's just 15%, which honestly, when you look at the timeline, makes total sense.
Yeah, they literally cannot afford to wait around for romance.
Exactly. If their partner from last year is late returning to the colony, they immediately pair up with someone else because the window for breeding is just incredibly tight.
If the biological drive to reproduce before the season turns just supersedes any kind of long-term pairing. So once they pair up, the female lays a single, pale, greenish-white egg.
And that egg weighs about 460 to 470 grams. But here's the wild part about those numbers. That egg is only 2.3% of the mother's body weight.
Right.
It is literally one of the smallest egg-to-mother weight ratios of any bird in existence.
Because producing a massive egg would demand massive energy reserves.
Yeah.
And the female simply doesn't have those reserves to spare because she is about to walk 100 kilometers back to the ocean just to eat.
But before she can make that trek, they have to do the egg transfer. And this is the moment of absolute maximum peril.
Oh, for sure.
The mother has to carefully roll this egg from her feet over to the male's feet. If that egg slips and touches the freezing ice for more than 1 or 2 minutes, the chick inside dies instantly.
Yeah.
And if the egg dies, the couple doesn't try again. They immediately split up, abandon the breeding season entirely, and just walk back to the sea.
The margin for error is essentially zero.
Wait, hold on, though. I'm looking at this whole timeline. If the margin for error is absolute zero, why on earth do they choose to breed in the absolute dead of the Antarctic winter?
It seems counterintuitive, doesn't it?
I mean, you're dealing with the darkest, coldest months of the year. Doing this when the weather is at its most lethal seems like an evolutionary death wish.
Well, this is a classic example of an extreme evolutionary trade-off. It is all about timing the chick's development. Think of this winter breeding cycle like an incredibly slow-burning fuse. Breeding in the dead of winter ensures that the chick slowly grows and develops over those harsh months. When it finally fledges, meaning it grows its waterproof juvenile feathers, and actually needs to enter the ocean to feed itself, that specific moment aligns perfectly with the Antarctic summer in December and January.
Because that is when the oceans are richest in food.
Precisely. If the adults waited for the warm summer to start breeding, the chicks wouldn't be ready for the water until the following autumn.
Oh, right.
They would be forced to learn how to hunt right when the ocean's freezing over again and the food supply drops drastically. So they are enduring the winter so their children can survive the summer.
They are playing an incredibly painful long game. So once the female successfully transfers that egg to the father, she leaves. And the male is left completely alone with the egg, kicking off one of the most grueling survival tests in the animal kingdom.
Yeah, the male incubates that egg by balancing it carefully on the tops of his feet. He tucks it under a warm fold of skin called a brood patch, keeping it safe from the ice for 65 to 75 days.
And he does not eat a single thing during this entire period.
Nothing at all.
By the time that egg hatches, the male will have been fasting for a total of 120 days since he first arrived at the colony. He can lose up to 20 kilograms, which is half of his entire body weight.
It's staggering.
Just picture what that looks like. You start with this massive, robust animal, and after 4 months in the dark, you have an emaciated bird, feathers ruffled, dull-eyed, completely running on biological fumes, just standing there.
Standing there in temperatures that routinely plummet to minus 40 degrees Celsius, while being battered by winds howling at 200 kilometers per hour.
To survive that kind of exposure, the males form this massive, tightly packed huddle, which is often referred to as a turtle formation. But it's not just a static group hug, it's an incredibly complex, highly coordinated, slow-motion stadium wave for survival.
Right, because everyone has to take a turn.
Exactly. The guys on the outer upwind edge of the circle are taking the absolute brunt of the frozen storm. But slowly, the entire mass shuffles. The ones on the outside peel off and move to the sheltered leeward side of the group.
Everyone constantly rotates through the warm center and the freezing outer edge. Without this churning collective behavior, the birds on the outside would freeze to death and the birds in the middle would overheat.
Which is just brilliant.
It really is. But the true astonishment is what happens when the egg finally hatches. The chick emerges completely helpless. The scientific term is semi-altricial.
And the father has been starving for 4 months. He has lost half his body weight. He is literally dying of starvation, yet he somehow manages to feed this newborn chick.
Yeah, he feeds it crop milk, which is a highly nutritious secretion produced from an esophageal gland.
Calling it milk almost sounds too gentle. How is a starving bird producing anything?
Well, it is essentially the father's body liquidating its absolute last emergency physical reserves. The crop milk is 59% protein and 28% lipid. The father is sacrificing his final bodily resources to produce this thick, nutrient-dense paste. This biological trick is incredibly rare in the avian world, shared really only with pigeons and flamingos.
But he can only keep that up for a few days, right? The tank is completely empty. So right at the critical moment, around mid-July to early August, the females return.
Talk about perfect timing.
Seriously. But imagine this. You have thousands of females waddling back from the ocean into a chaotic colony of thousands of identical-looking males holding thousands of identical-looking chicks. How do they find their specific mate in all that noise and darkness?
They rely entirely on complex dual-frequency vocalizations. A penguin uses 2 separate vocal tracks simultaneously to produce a unique acoustic beat pattern.
That's wild, like singing 2 notes at once.
Basically, yeah. This creates a highly specific, penetrating acoustic signature that cuts straight through the howling wind and the noise of the colony. The female calls out, and the male responds, allowing her to pinpoint his exact location.
But, the harsh reality is that not every female returns.
No. The Antarctic environment is unforgiving. 10 to 20% of the females simply do not make it back. They fall victim to leopard seals, orcas, or sudden changes in the sea ice.
And when a mother doesn't return, a brutal tragedy unfolds in the colony.
Yeah.
Because the starving father can't keep feeding the chick on crop milk forever.
Exactly. He reaches a physiological breaking point where he is forced to abandon the chick in order to walk back to the ocean and save his own life. The environment just drives desperation.
Yeah.
And female penguins, who have lost their own chicks to the cold, or who never made it at all, will sometimes try to adopt or honestly violently steal an orphan chick.
Which, that seems almost sympathetic until you look at the mechanics of it.
Because it leads to massive, violent scuffles among the adults. Yeah. Often the chicks are crushed and trampled to death in the chaos.
Oh, that's horrible.
And even if a female successfully steals an orphan, it's a biological dead end. A single female cannot feed and protect a chick on her own while also foraging for food, so the chick inevitably gets abandoned again. It is a brutal illustration of how razor-thin the margin for survival truly is.
Which brings us to the most pressing issue right now. This entire intricate, perfectly timed, razor-thin survival strategy relies on one foundational element remaining constant, and that is stable, predictable sea ice. And right now, the floor is quite literally melting beneath their feet.
Yeah. In April 2026, the International Union for Conservation of Nature, the IUCN, officially declared the emperor penguin as endangered. And, looking at the scientific consensus impartially, the driving factor behind this status change is human-induced climate change. Specifically how global warming is causing the early breakup of sea ice.
Because satellite imagery tracking these colonies from 2009 to 2018 showed a 10% loss in the overall population. That is over 20,000 adult birds gone in less than a decade.
And the future projections are severe. Based on that satellite data, there is a 45% probability that the population will decline by more than 50% by the year 2073. Furthermore, modeling predicts quasi-extinction for 90% of colonies by the year 2100.
And for anyone listening who is unfamiliar with the terminology, quasi-extinction basically means a population threshold where there might still be a few living individuals scattered around, but the numbers are so low that the species is functionally doomed.
Right. They lose the critical mass necessary to maintain genetic diversity, or even, form those life-saving huddles we talked about.
But from a purely practical perspective, I have to ask, and I know a lot of people wonder this if the sea ice is melting, why can't a bird just move onto solid land or rocky shores to lay its egg? Like, why are they so strictly tied to the ice?
Well, it is a combination of geography and highly specialized anatomy. Their bodies are adapted to slide and traverse over flat, smooth ice. They physically struggle to navigate rough, rocky terrain. Yeah, and more importantly, their breeding colonies need to be within a very specific walking distance from open water foraging grounds. The solid land in Antarctica is often blocked by towering ice shelves, or is simply too far inland.
That makes sense.
If they move further inland to find solid ground, the 100-kilometer trek becomes a 300-kilometer trek, which is just physiologically impossible. They're biologically locked into the pack ice.
And the timing of the ice melting is the true killer here.
Let's go back to that slow-burning fuse. The chicks need time to grow their waterproof juvenile plumage. It is a slow molting process that takes about 2 months.
Right.
If the sea ice breaks up early beneath their feet, before those chicks have their waterproof feathers, they are plunged directly into the freezing ocean. Without that waterproof protection, the downy chicks simply absorb the water, sink, and freeze to death.
Which is just awful. And the Halley Bay disaster is a really devastating example of this. So Halley Bay used to be the second largest emperor penguin colony in the world. But between 2015 and 2018, an incredibly strong El Niño event, combined with unusually high winds, resulted in record low sea ice.
It was unprecedented.
Yeah, the ice broke up months too early. The colony suffered almost total breeding failure, with thousands of chicks dying for 3 consecutive years.
And some adults did attempt to relocate to another colony 55 kilometers away. But the population increase at the new site was just a tiny fraction of what was lost at Halley Bay. It proves they cannot simply migrate out of the problem.
Right.
They're also highly sensitive to other human disturbances. Helicopter tourism, for example, causes intense stress. Observers note that chicks huddled in a creche, which is a defensive group formation, become noticeably apprehensive and stressed when a helicopter approaches even within 1,000 meters.
Because their icy world is changing so rapidly and unpredictably, we are also seeing these incredibly specialized birds occasionally showing up in places they absolutely do not belong. We are seeing records of vagrant penguins wandering thousands of miles away from the Antarctic Circle.
Yeah, it strongly highlights the disruption of their environment and suggests severe navigational confusion caused by shifting ocean temperatures and currents.
I'm sure you probably remember the famous case of Happy Feet, the juvenile penguin that washed up on a beach in New Zealand back in 2011.
Oh, yeah.
He was completely out of his element. He was so overheated and confused that he ate 3 kilograms of wet sand, mistaking it for snow, just to cool his internal temperature down. He required multiple extensive surgeries to survive before researchers could finally release him back into the ocean.
It's so sad.
And just recently, in November 2024, a group of surfers in Denmark, Western Australia, were out in the water, and an emperor penguin simply waddled up onto the beach. It is the furthest north a vagrant emperor has ever been recorded.
And, even attempting to keep them in captivity to study them or help them is notoriously difficult, precisely because of those extreme biological adaptations. Early attempts in the 1930s and 40s to house them in zoos were almost entirely fatal.
Wow, really?
Yeah, until facilities like the Elborg Zoo in Denmark engineered highly specialized, climate-controlled chill houses. They simply are not animals that can pivot and adapt to a different environment.
Which is such a contrast to how we see them. Culturally, we love to anthropomorphize them. We put them in blockbuster documentaries like March of the Penguins or animated movies like Happy Feet. We love the idea of them as these resilient, dancing, singing characters.
Yeah, we really do.
But in reality, they are serious, intensely powerful animals. There's a historical account in the sources where a crew of 6 grown men tried to capture a single 40-kilogram male penguin for an exhibition. This one bird repeatedly tossed all 6 men around the ice, knocking them over with its flippers until they had to collectively tackle it to the ground just to subdue it.
Because they are built like compact tanks of pure muscle. The contrast between our cultural image of the penguin and their biological reality is striking. Their reality is a masterclass in stoic, unforgiving evolutionary adaptation. They do not survive out there through sheer willpower or bravery.
Right.
They survive because of millions of years of highly specialized biological engineering.
And that brings us full circle. From holding their breath for 20 minutes at 500 meters deep in crushing pressure to enduring a 120-day fast in minus 40-degree winds. We have looked at the incredible extremes they push their bodies to and how precariously their entire existence balances on the edge of a melting sheet of sea ice.
It really redefines what endurance actually means on this planet.
It absolutely does. But before we wrap up this deep dive, I want to leave you with one lingering thought to mull over, something we found buried deep in the taxonomy notes.
Oh, this is a good one.
Yeah, fossil records show that an ancient ancestor of the emperor, a species called Ridgeon's penguin, lived in New Zealand around 3 million years ago. That was during the late Pliocene epoch, a geological time when the Earth was significantly warmer than it is today.
Right.
Which begs a fascinating question for you to ponder. If their ancient ancestors thrived in a warmer world 3 million years ago, could the emperor penguin theoretically evolve to survive a warmer climate again, given enough millions of years? Or is the current speed of our changing world simply far too fast for the ultimate ice specialist to adapt? It makes you wonder, the next time you picture that pitch black, freezing water and holding your breath, are we witnessing the final incredible deep dive of the emperor?